If your truck keeps killing batteries, is it really the battery's fault, or is the charging system lying to you? Most new mechanics assume that when batteries won't stay charged, the batteries must be bad. But in heavy duty vehicles, that assumption causes more repeat comebacks than almost anything else. By the end of this video, you'll understand how heavy duty charging systems actually work, why batteries are often unfairly blamed, and how to avoid guessing when diagnosing charging problems. But let's start with the big picture. The charging system has three main jobs. Number one, to supply electrical power while the engine is running. Two, to recharge the batteries. And three, to maintain stable system voltage. But here's something many new heavy duty techs miss. Once the engine is running, the batteries are no longer the main power source, as the alternator should be doing most of the work. But if the alternator is weak, what happens to the batteries while you're driving? Well, they slowly discharge even though the engine is running, as they aren't given a chance to recharge after starting. But speaking of the starting system, let's separate these two systems, the starting and the charging systems, as they get confused all the time. The starting system has a very short duration. It uses extremely high current, and it really only works during cranking. On the other hand, the charging system runs continuously, handles a steady electrical demand, and powers everything from lights to engine computers. A vehicle can crank fine today and still be killing batteries tomorrow if the charging system is weak. A heavy duty charging system is built around the alternator, the rectifier and diodes, the voltage regulator. Most of these components are internal to the alternator now, but they may be external in some applications, along with batteries, cables, and grounds. And each component depends on the others. Think of it like a chain. One weak link can affect the whole system. But the alternator is really the main star of the charging show, and it converts mechanical energy into electrical energy. It's typically belt driven or possibly gear driven, and it produces AC voltage internally. Heavy duty vehicles work almost entirely with DC voltage, and we will get into how that works shortly. The alternator output also increases with engine speed or RPM. Heavy duty alternators are designed for high amperage, long run times, and heavy electrical loads. Inside the alternator, electricity is produced as AC voltage. But since vehicles run on DC voltage, it's the job of the rectifier and diodes to convert that AC to DC and allow the current to flow in only one direction. This prevents battery discharge back through the alternator. But these diodes, which allow current to only flow in one direction, can cause low output, unstable voltage, or electrical glitches if they fail. This is why some charging problems can feel kind of random. The voltage regulator controls the alternator output, and its job is to prevent overcharging, to prevent undercharging, and also to adjust output based on system demand. On heavy duty vehicles, regulators may be internal, external, or ECM controlled. But what's worse in the real world? Too much voltage or not enough? Well, too much voltage is just as damaging as too little voltage. In a moment, you'll see why undercharging often kills batteries faster than undercharging. And batteries don't just start the engine, they also help to stabilize the system voltage, absorb some of the voltage spikes, and can act as a buffer during load changes. Heavy duty vehicles commonly use multiple batteries, and they may have complex battery configurations or setups. Weak batteries stress the alternator, and a weak alternator can kill batteries. It's a cycle. But now let's cover something that confuses a lot of new techs: how batteries are connected and how they're charged. If you don't understand this, your voltage readings aren't going to make any sense. In a parallel battery setup, all positives are connected together, and all negatives are connected together. This gives you the same voltage and more capacity. Two 12-volt batteries in parallel, as shown here, is still 12 volts, but has more available current. These are common on trucks, buses, construction, and ag equipment, along with vehicles needing long run times. But what happens if one battery in parallel is weak? Well, it drags the good batteries down, which can overload the charging system. On the other hand, in a series setup, the positive of one battery connects to the negative of the next. And this gives you a higher voltage and the same capacity. Two 12-volt batteries in series creates 24 volts. These are also common on some heavy-duty trucks, some buses, and industrial equipment, along with some construction and ag as well. The charging system, however, must charge both batteries evenly. Some large industrial or heavy machinery may also use a series parallel system. In this case, the series portion increases the voltage, and the parallel part of it increases capacity. This allows for a higher voltage, long operating time, and heavy electrical demand. But all of these systems only work properly if the batteries are matched, the connections are clean, and grounds are solid. But no matter which system you're up against, you'll need to understand voltage readings. Voltage readings depend on the system design, and voltage readings will depend on whether the engine is off, which will indicate battery voltage only, or if the engine is running, this will show the charging voltage, However, voltage should rise after startup, then voltage should remain stable. That's because the starting system requires a ton of power to crank the engine over, which uses lots of amps and depletes the batteries, which in turn lowers their voltage. And if voltage isn't stable, this can cause warning lights to come on, sensor faults, and module failures. But let's talk about some real world failures and where they come from. If you have loose or slipping drive belts, the alternator won't spin properly to convert that rotational movement into electrical energy. If you have corroded battery terminals, the energy created by the alternator will be lost as heat at the corrosion, rather than going into the batteries as it should. Poor grounds also act as another source of unwanted resistance. Failed regulators, these can result in over or undercharging as we mentioned earlier, or some internal alternator issues such as failed diodes, which could result in weak charging. Always start with a visual inspection, check out your belt condition, and check your battery and cables. Then, if those all check out good, you can check out your overall battery voltage, you can check your charging voltage along with your individual battery testing. There's also voltage drop testing on cables that can find hidden resistance, bad grounds, and poor connections. The charging system powers everything while the vehicle or machinery is running. The alternator, regulator, and batteries all work together to keep everything running smooth. Now, I just mentioned voltage drop, and if you need a bit more understanding on what that means, watch this video next to learn all about that.